Okay, folks, so in lesson 2 of differential equations part 2, I'm going to introduce you to a phenomenon known as simple harmonic motion, which is usually abbreviated as SHM. This is a simple mathematical model of oscillatory behavior. And I know those of you who do physics will have encountered it, I think, in that. But I'll try to explain to you what the further maths approach this is. Now, before we look at our pack, I just have a little introduction I would like to show you for a couple of minutes, just to introduce and animate what's going on. So simple oscillation, SHM, is a simple model for oscillating motion. So the kind of situation we might be interested in is an object which is oscillating either up or down, or maybe left or right on the end of a spring, or the displacement of an object which is swinging from side to side on a pendulum. That's the kind of thing that we might be interested in. Now, bit of this background here, you're not going to need to know this in full detail, but I think it is important to have some idea where it comes from. So the idea of simple harmonic motion is you will have some object which will have some sort of equilibrium position, a starting position. If we stopped it moving, that's where it'd stay in place. So let's imagine situation A, where we have a spring which is has a weight on the end of it. If you were to stretch the spring and let go, the object at the end would oscillate up and down, up and down. At some points, the spring would have some sort of an extension, X, and at other points, the string would have a contraction, which means the same as a negative extension. So the extension, which could be positive or negative, is a displacement from its equilibrium position. Now, there is a famous law about springs known as Hooke's law. Hooke's law tells us that the resultant force acting on a mass is proportional to the extension and in the opposite direction. A consequence of this is that the acceleration of the object is going to be proportional to its displacement and in the opposite direction to its displacement. So this means that A is minus kx. A, the acceleration is proportional to x, but it's proportional and in the opposite direction. If it's being stretched downwards, it's accelerating upwards. If it's being squashed upwards, it's accelerating downwards. Now, this is normally written as a differential equation in the following way. The acceleration is d2x by dt squared. K is a positive constant, so minus k is negative. It is convenient to write this as minus, that's not a w there, that's an omega squared x. So simple harmonic motion will lead to a differential equation of this type. Right, folks, let's see what it has to say on this matter in your packs. Let's get a bit bigger. So SHM is a common way to model the motion of a particle oscillating backwards and forwards, or up and down. The particle moves in such a way that its acceleration is always directly towards a fixed point on its path, its equilibrium position, its center of oscillation. The acceleration is proportional to the displacement of the particle from the object. You're always going to get a differential equation of that form. And there's various other things that we might be interested in. We might be interested in the maximum distance the object is away from its center of oscillation. That's called its amplitude. We might be interested in the time taken to perform one oscillation. That is the time period. Now, guys, what you're not going to have to do is really do loads and loads of maths to derive a differential equation of this type. It's quite likely that such a differential equation will be given to you. Can I just do a couple of simple situations before we move on to something that's a little bit more exam condition-like? So I'm asked to do the following. Solve the following differential equations for simple harmonic motion subject to the boundary conditions, and then we'll sketch a graph of x, the displacement against time, and state the amplitude and time period of the motion. So the first one I'm interested is in d2x by dt squared is minus 25x. That's a differential equation of this form. I'm told initially when t is 0, the displacement is 8 and the velocity is equal to 0. Now, if you were doing this as a physics student, you might be expected to just write this down. As a further maths student, you're supposed to solve this differential equation, which we can do by getting everything across to one side. So this differential equation is the same as d2x by dt squared plus 25x is equal to 0. So this is a second order differential equation involving a variable x and its second derivative d2x by dt squared. These are solved by writing down an auxiliary equation, which in this case is m squared from the d2x by dt squared. There's no dx by dt term, so there's no n term in the auxiliary equation, plus 25 is equal to 0. That is my auxiliary equation. This can be solved on your calculator, or you can say m squared is minus 25 to give a solution of the form m is plus or minus 5i, where I is the square root of minus 1. So the solution to this, it would have the form y is, let's write this down over here, but we're not going to write this down somewhere away. It would have the form y is e to the px into a cos qx plus b sine qx. But we have to change a few letters. Y is now x in this question. X is now t. Because it's plus or minus 0. Plus or minus 5i, p is actually 0 and q is equal to 5. So therefore, the general solution of this differential equation is x is equal to e to the pt, which is e to the 0 times t, into a cos qt, a cos 5t, plus b sine 5t. But wait a minute, e to the 0 is always 1, so therefore that's just x equals a cos 5t plus b sine 5t. That's the general solution. Now we can work out a and b by subbing in the boundary conditions, the initial conditions. When t is 0, x is 8. So if you sub that in, you get x is 8 is a times the cos of 0, but the cos of 0 is 1, so that's just a, plus b times the sine of 0, but the sine of 0 is 0. So that means a is 8. To use the fact that the velocity is 0, I'm going to differentiate this to get the velocity, because the velocity is dx by dt, which is going to be, therefore, minus 5a sine 5t plus 5b cos 5t. When t is 0, the velocity is 0, so therefore 0 is equal to minus 5a times sine of 0 is 0, plus 5b times the cos of 0, which is 1, so 5b, so therefore b is 0. So consequently, the equation for this object's motion is x is a cos 5t, but a is 8 cos 5t plus b sine 5t, which is 0. So there you go, folks. There's the solution of this. I'm now going to sketch a graph of t against x. X against t. You can absolutely use your calculator to help you with this, but you should be able to do a good job on this. This is the cos graph. It's been stretched by 8 in the vertical direction, which is in this case the x direction, and stretched by 1/5 in the horizontal direction, which is the t direction. So what that means is this is the graph of this function got by taking the original cos graph. That point is 8, that point is minus 8. The original cos function has a period of 2 pi, we've stretched it by a fifth, and therefore it's 2 pi over 5. So there's my graph. And from this graph straight away, we can deduce the amplitude. So the amplitude is the maximum displacement. It's the maximum value of x. So the amplitude is 8. And also the time period is the time for one oscillation. Well, that is 2 pi over 5. There's my first one. Example 2. Similar differential equation, this time when t is 0, x is 0, v is 6. So d2x by dt squared is minus 9x. In a very similar way before, this gives d2x by dt squared plus 9x is equal to 0. The auxiliary equation is m squared plus 9 is 0. Solving that gives m is plus or minus 3i. Therefore, the general solution for x in terms of t is going to be x is e to the 0 times t, which is just 1, into a cos 3t plus b sine 3t. To work out a and b, when t is 0, x is 0, so you get 0 is a times the cos of 0. Well, that's just 1, so that's just a plus b times the sine of 0, which is b times 0, which is 0. So therefore, a is equal to 0. So consequently, we can get rid of that term, and we know that x is equal to b sine 3t. To work out b, I'm going to use the fact that the velocity is 6. So v is dx by dt, which is 3b cos 3t. Sub in v is equal to 6. And t is 0, so 3t is 0, and cos of that is 1, is 3b, so therefore b is 2. So the equation for this object's motion is x is equal to a is 0, b is 2 sine 3t. Again, we can sketch a graph of x against t, t against x. So this time, this is the sine function, which goes through the origin. It's been stretched by 2 in the y direction, which is actually the x direction, and a third in the t direction. So this is going to look like that. There's the sine graph. That is going to be 2. That is going to be minus 2. This point here would be 2 pi, but you've stretched it by a third. Is 2 pi over 3. So consequently, the amplitude, the maximum displacement, is equal to 2, and the time period for this motion is 2 pi over 3. Whoops. Example 3, again, a similar one. This one's going to get a bit more complicated, as we'll see in just a second. So d2x by dt squared is minus 4x. And we've got various boundary conditions. Worry about that again. So again, as before, this gives d2x by dt squared plus 4x is equal to 0. There are loads of students leaving an exam at the moment, in case you want to hear the background noises. This gives an auxiliary equation, m squared plus 4 is 0, which means m is plus or minus 2i. So therefore, x is equal to a cos 2t, but it's e to the 0t in front, but that's just 1 plus b sine 2t. When t is pi over 8, x is 2 root 2. So that's going to give me 2 root 2 is a times the cos of 2 pi over 8. 2 pi over 8 is pi over 4, and cos of pi over 4 is root 2 over 2. Plus b sine of 2 times pi over 8, which again is pi over 4, and sine of that is also root 2 over 2. And that's a simultaneous equation. You can divide by root 2 and times through by 2 to get 4 is equal to a plus b. We also know when t is pi over 4, x is 8. So that gives 8 is a times the cos of 2 pi over 4. Well, 2 pi over 4 is pi over 2, and cos of that is 0. b times the sine of 2 pi over 4, or sine of pi over 2 is 1, so that means 8 is equal to b. So therefore, because a plus b is equal to 4, it must be true that a is minus 4. So therefore, x is equal to, let's get the sine term first, 8 sine 2t minus 4 cos 2t. So that's the equation linking the motion of this object. Now, sketching a graph of this is a little bit tricky. I have done it on my calculator. If it's going to work, here's one I prepared earlier, folks, by playing around with the axes. 8x, I had to put y is 8 sine 2x minus 4 cos 2x. That's what the graph looks like there. So algebraically, if it was required, work out the says might work out the amplitude. I'm going to rewrite this function in the form, bit of A-level maths for you folks, r sine 2t minus alpha. I can go rid of that, folks, ladies and gentlemen, boys and girls. So by some standard A-level math stuff, so this means that we're going to get that 8 sine 2t minus 4 cos 2t is equal to, if you expand that using sine A minus B, you get r sine 2t cos alpha minus, oops, sorry, wrong there, r cos 2t sine alpha. So that's going to lead to that r cos alpha is 8 and r sine alpha is equal to 4. That's by comparing coefficients. If you square them and add them, you get r squared, because cos squared plus sine squared is 1, is 8 squared plus 4 squared. So r turns out to be 4 root 5. If you just square that, square root it. If you divide these two equations, you get tan alpha, because the r's cancel, is 4 over 8, which gives alpha is in radians 0.464. So putting all that together means that x is equal to 4 root 5 sine of 2t minus 0.464. So the graph you'll know looks like a bit like that. So let's come back to me here. Looks like that. I can use this form here. Let me just change the color a little bit. To work out the amplitude, that gives me the maximum value of, you've got a sine graph that's been stretched and also translated in the x direction and then stretched in the y direction. So consequently, its amplitude, its exact amplitude is 4 root 5. Your calculator, if you ask it to find the maximum value, it will give you 8.94, but that's what 4 root 5 is. The time period we can also deduce as well. This bit here means the sine graph is translated in the x direction by 0.464 and then stretched by a half. The original sine graph has a period of 2 pi radians. Stretching it by a half gives a period of just a pi radians. Okay, folks. So, guys and girls, those were just some elementary examples just to introduce you to this. This following is true. You're not expected to learn any of this. You deduce this by solving differential equations. For a particle P whose motion is modeled by this simple harmonic motion, by solving a differential equation, the general solution is A cos omega t plus B sine omega t. The period is 2 pi over omega, because the sine and cos graphs have been stretched by 1 over omega in the x direction. If the object starts at the origin, its fixed point, its center of oscillation, its equilibrium position, x is A sine omega t, where A is the amplitude. It could start from a point of maximum displacement, in which case x is a cos omega t. Otherwise, it can be rewritten in the form x is a sine omega t plus alpha. Now, students, here is my confession. Actually, what you're going to get in an exam isn't like what's going to happen in today's lesson. It's what's going to happen in the next lesson, which is an extension of this. But this feels like an exam question-ish on this matter. So one end of a light elastic spring of unstretched length 2 meters is fixed to a point O on a smooth horizontal table. Can I try to draw a picture to illustrate what's going on? This is my smooth horizontal table, and I've got a spring which has one length at O. A particle of mass 0.1 kilograms attached to the other end of the spring and is rests in equilibrium at a point A on the table. So consequently, that's the unstretched spring, that's 2 meters. There is my particle. So unstretched string, that bit is 2 meters. The particle is then pulled away from A, causing the string to stretch by 20 meters, 20 centimeters, sorry, so it's pulled away from here. And the force in the string is directed towards A and has a magnitude of 10x, where x is in meters. Is the displacement of the particle from A. The body is released at rest at time t is 0 seconds. Right, let's prove this differential equation holds. So what's going on, folks, is this. It will have a force F equal to 10x, which is pulling it back towards A when its displacement is equal to x. So consequently, if you use F equals ma for this object, and I'm going to take to the right as positive, the force acting on it is minus 10x. This must be equal to its mass, which is 0.1 times its acceleration. That's what F equals ma gives you in this case. Now, I can rewrite this as this differential equation because A is d2x by dt squared. So minus 10x, minus 10x is 0.1 d2x by dt squared. If you divide both sides by 0.1, which is the same as multiplying by 10, and swap the sides over, you get d2x by dt squared is minus 100x. That's part A. B. Solve this differential equation to prove that x is 0.2 cos 10t. So the way of solving these differential equations is to get them all equal to 0. d2x by dt squared plus 100x is 0, and write down the auxiliary equation m squared plus 100 is 0. If you solve that, you get m is plus or minus 10i. The general solution is that x is equal to e to the 0t, which is just 1 a cos 10t plus b sine 10t. Now, how to work out a and b? Well, we're told it's released from rest at time t is 0, and when it's released, the extension is 20 centimeters. So this means when t is 0, x is 20 centimeters, which is 0.2 meters, and the velocity is 0. If you sub in t is 0 and x is 0.2, you will get 0.2 is x is equal to a times cos of 0, which is a times 1, which is a, plus b times sine of 0, which is 0. So a is 0.2. The velocity is dx by dt, which is minus 10a sine 10t plus 10b cos 10t. If you sub in t is 0, v is 0, you will get 0 is equal to minus 10a times sine of 0 is just 0, plus 10b times cos of 0 is 10b. So b is equal to 0. So if you put all that together, you get that x is equal to 0.2 cos 0.1t. Excuse me, as was required. Remember that x is 0.2 cos 0.1t. It then says on the next page, ladies and gentlemen, boys and girls, remember this, x equals 0.2 cos 0.1t. Oh no, was that right? X is 0.2 cos 0.1t. It was right. Calculate the distance of the particle from O when t is pi over 30. Well, the distance of the particle from O is its displacement. It just means find x. So therefore, x is 0.2 cos of 0.1 times pi over 30. If you sub that into your calculator, ladies and girls, that will give me minus 0.1. Wait 1 minute. That is the distance of the particle from A. So if you go back to this picture, it's slightly annoying. We've got to go here. What that means is that point in time, let me go blue, ladies and gentlemen, boys and girls, it's at this point here where that distance is 0.1, because it's 0.1 in the negative direction. Therefore, the distance from A is 2 take away 0.1 meters. So OA, so distance to the point O, sorry, distance to O is what I wanted. Well, distance to A is minus 0.1, distance to O is 2 minus 0.1, which is 1.9 meters. Calculate the speed of the particle when t is pi over 3. Well, the speed can be got by finding the velocity. The velocity is dx by dt. If you differentiate this function, you will get minus 0.02 sine 0.1t, which is minus 0.02 sine of 0.1 times pi over 30. Now, guys, if you plug that into your particle, how did I get that? Oh, I've got it wrong. Sorry, students, earlier mistake. That should have been a 10. That should be a 10. So that should be a 10. So consequently, that should be a minus 2. All right? So that is still minus 0.1. That's correct. My error. So that's minus 2. So its velocity is minus 2. Speed has to be positive. So therefore, the speed is 2 meters per second. Okay, folks. Sorry, that's me copying down from the previous page wrongly. Right, ladies and gentlemen, you are now in a position where you can do exercise 2. Can I just warn you a bit of notation that they use? In some of the questions, they'll talk about x double dot. X double dot is just a notation that means d2x by dt squared. Okay, folks. Sorry, my mistakes. You may now do the work.